Hi, I'm Daniel Padzunas, and today the physics problem we're going to be doing is a football player kicks a ball 15 meters per second at 40 degrees to the horizontal. So first of all, how far would it go? Then we're going to see how high it would go at the maximum point. And then would it be able to pass through a 3-meter tall goalpost that's 20 meters away, given those values? Okay, so first let's look at the formulae that we're going to need to use. So first is pretty simple. It's just the velocity formula, distance over time, or displacement over time. We're going to need to be able to use the displacement formula, vertical acceleration times time, plus 1/2 acceleration times time squared. We're also going to need to know the acceleration formula, which is vertical, or final velocity minus initial velocity divided by time. You're also going to need to know some basic trig. All right, so first, known and logical information. So as of current, other than the fact that it's going 15 meters per second at 40 degrees, we don't really know anything other than that, and also what the accelerations are going to be for the vertical and the horizontal. So what we're going to need to do is we're going to need to draw a diagram just to show this. So what we have is we just draw a triangle. 15 meters per second over here, and then 40 degrees here. And then by using that, we're going to be able to find out with these what the horizontal and vertical velocities are. So with this, we find that the vertical velocity is 9.642 meters per second, and we find that the horizontal velocity, well, the initial velocities, are 11.491 meters per second. Okay, so now we're going to go back over to the chart. So we could fill in our initial velocities for both of these, with horizontal being 11.491, and the initial velocity for vertical being 9.642 meters per second. Okay. Well, based on the acceleration and also just basic logic, we can also figure out what the final velocities will be for both of these. So with the horizontal, due to the fact that there's no acceleration, we know that at the end it's still going to be 11.491 meters per second. And then for the vertical, we know that, at equal points in flight, an object going to have the opposite velocity, which means that the final velocity for this overall, right the instant before it hits the ground, it's going to actually be negative 9.642 meters per second. Okay, so we finished with that. So now that we have these values, we'll be able to find time pretty easily. So what we need to know here is the acceleration formula. Now, we're just going to rearrange this so that we end up getting t equals the negative initial velocity divided by acceleration. Now, we did this based on this little chart of its flight. So the part that we're focusing on here is this part right here. So from the max to the start. So we see that the initial velocity is 9.642, but because the final velocity is 0, we can just get rid of that right off the bat. So after we, do the math based on this formula, shown here, we end up getting that the time for just this segment is, well, it's going to be half of the final time. So what we would do is we would multiply the answer here by 2. So what we end up getting for the total overall time is 1.968 seconds. So we'll just write that over here as well. And obviously it's going to be going for the same amount of time both horizontally and vertically, because as soon as it hits the ground it's going to stop in both ways. Alright, so now that we have the time as well, we could easily find the displacement, the distance, and all that stuff. Alright, so we're going to be using really the same formula for both. For the vertical, we're going to be using the displacement formula shown here. and then we would plug in our values. So we have the vertical, or the initial velocity, times the time, plus plus half, 1/2 times the acceleration times time times time. However, as you can see, I divide every single time we see the time, I divide it by 2. Because if we look at the time over here, at the total time, it's going to be at the ground, which means that there's going to be 0 displacement here. What we're trying to find is the max height, or half of the time. So that means that we're going to be needing to be dividing the time by half when we're trying to find the max height, because it hits it at halfway through. And once we solve, we get 4.744 meters. And then for the horizontal, because there's no acceleration, we could just get rid of this entire part of it. So what that means is that we're left with this, and then once we do the math, we find that it goes 22.614 meters. So that's the total distance. So that would be the answer to these first 2 parts of the problem. So we got this done, we got this. So now all we have left is, could it pass through a 3-meter tall goalpost 20 meters away? All right, so now this is the final part. So first of all, we need to find the time that it takes. So this is where the basic velocity formula comes in. So because we know that velocity is displacement over time. Well, we can arrange that to be time equals displacement divided by velocity. Now we know that the horizontal velocity at all times is 11.491 meters per second. So that means that it would take a total of 1.74 seconds to cross that entire distance. Well, after that, we can use that time to find what the height's going to be. So we know that the height is, so now we can find the height, basically, now that we know the time. So we're going to be plugging the time into our displacement formula, and what we end up getting is that the height at that point in time is only 1.938 meters, which is less than 3 meters, which means that no, it's not high enough. It would actually end up coming short about 1.6 meters, which means that we just solved our final part. All right, so thanks for watching.